we have a monashell system by filter system with media inside. We have two stages of media. So we have a wall that separates the civil work, the basin.
Yes.
We have a wall, and we have the first stage of media and the second stage of media. The first stage, why? Because it's here enter the air, then the air go through the media, pass in this point, and go through the second stage media, and then go up. So this is the first system. The media is wetted from a recirculation system. So we have a sump here with two pumps, and we have a connection between the bottom of the biofilter to this sump that is separated by a 300 millimeters, like 2 inch. The water passes here and is pumped in pressure to the media. We will see. We will see on site.
And there's two stages for a reason, just not for the basin situation, but ultimately, as you can see, as air comes in, you have two modes, concurrent and co-current, and H2S being extremely soluble. First stage, we're mainly dealing with that. Then we're going against the air into the water, and then we're going over the wall into a different type of shell media going with the water, and that's where we're doing the polishing. And that's when you're growing your bacteria that are dealing with more VOCs, mercaptans, reduced sulfur compounds, dimethyl disulfide, things like that. And that is the key of having the two chambers in the media, how it is. And I know that we've designed this in a robust way to operate in 3 modes. Our suggestion at AirClean is to run it with both stages, because your carbon life is going to be forever. It's basically getting less than 1 ppm, a half a ppm. So I don't think you have it. So I would run it in that configuration, just because I don't think you have any media life situations where you're worrying about burning things up. And the way that we have the permissive and lockouts designed is to do media changes. I know there was a lot of talk about how, dampers and how we were going to do this, but it's designed as we would do anything in a configuration that we would more or less say lockout, tag out, which means that you can fully service either the carbon system or the biofilter while running odor control and having people in there, because the blind flanges basically lock everything out so that you can continue odor control and service an entire portion of the system without having any safety factors.
Also, we have planned, for example, with bioclicking filter with 100 ppm of H2S, so very high. Normally, if you put only carbon, this should be saturated in very quick way. While we put normally the bioclicking system to low, you give 95% of efficiency. So imagine you have 100 ppm, go out with 5 ppm and go to the carbon. In this case, I don't think you have 100, so we will have 20 ppm. So reduce the H2S at very low level. I picked this mode because the system should work in 3 modes. So only the biotrickling, only the carbon, or both. This is also a way you want to change the material. You have some problem. Okay, you close one system, you make them working. In each P&I, I set this. We have some damper. So depending on how we set the damper, we have one mode or the other. For example, at the inlet of the system, you have one normally open connection, one damper here. So for sure, if you wanted to work with the OC biotrick, this should be open. Then you have another one here. Okay, this is a bypass that goes directly to the carbon system. So if we want to use the bioclicking, this should be closed. And also this should be open. Why this? Because also the panel has this 3 mode. How we set, it's important that we choose a configuration, and then we set the control panel in this configuration, and we leave it. The only thing that they have to manage, okay, how we want to work the system, in only the biotricking, only the carbon, only the both, and we set the damper. When we set the damper, then we start the system in auto mode. So only this is, we have one blower, switch on, off. There is a VFD that controls the frequency of the motor. We will give you some parameter how to set. I put the frequency for the treating the airflow.
Yeah, we're correlating the data now with the anemometer.
Then we have 2 pumps that normally work all the time and recirculate the system. The pump are controlled by level. Okay, so we have a minimum low level that stops the pump, and when this go up, restart the pump. So are protected from dry. Okay, there is another little issue, but we need to know. The grid of the monashell is high, more or less.
3.3 feet-ish, yes.
In this space, there is air and water. So it's important that for keeping air, so for suction, that all this chamber should not be overflooded. So if you see, we keep a level of 3 feet. So here in the sump, we have an overflow at 2 feet. So for sure, all the water arrive if go up the 2 feet is sent away from the overflow. So this is safe to keep a space in the distribution chamber to have the air coming from the section that we take. As a redundancy, we place a second high level that give an alarm in case the overflow for some reason was blocked, should be blocked, and so we have an alarm here. So we have. So in this case, people go inside and check what happened.
There's also a pressure switch for the pumps that is set on a right now 10-second timer to make sure the flow is going. So it's 10-second delay. And then obviously once the pump kicks on and the pressure is satisfied, then it will trip off. But if it never starts and the pressure alarm times out, it will put a fault and alarm on the panel.
Now we put the water in all the system, at the bottom. We start the pump, but what happened? The media take some water, so still water from the bottom. So now the system are working up and down because you steal the water here, the water stay in the media, and the level here is we have a charging water line. We will leave all the time open.
Decided that the calculations was 1 gallon per minute.
So the idea is, then I will write whoever we can discuss about this. We have about 30 cubic meter of water inside. Normally, to keep clean this water, okay, if the water, imagine we recirculate this water for 1 year, no changing and all. So at the end, what happened? That this water became very dirty, smelly. It's a problem for the air because if the water is dirty, the air also is dirty outside. So we will have a problem. So normally, an idea or how the system is working is to only give a look to the water.
So the part of this is that what you're probably used to in biotrickling filters in general is plastic media that's being dosed either with 10-10-10 or whatever inoculants are using and operating in a low pH environment, mainly targeting H2S. In that case, you have to blow down the sump a lot because you're getting really low negative numbers. Ours operates at between 6 and 7, little over pH, and that's where we want to grow the bacteria because we're dealing with the calcium from the shell. So the shell's very robust, but there's a lot of surface area for them to grab onto, the microbes. And when you have ones that are turned upside down that are filling with water, you're getting different anoxic bacteria inside there. And the key is the calcium is then bleeding off as the wash water is absorbing soluble H2S, and the calcium is buffering it back so that we are keeping the bugs alive. What makes that great is the second stage can now grow different bacteria to deal with these other constituents, mercaptans and things like that you won't get from a normal biotrickling filter. There's not a lot of load here. I don't expect very high loads. So the cool thing about having balanced pH in this ecosystem, I call it in there, of all these happy bugs constantly eating each other, is that you can have very low input, below 1 ppm of H2S, and you will keep the colony alive. It doesn't need a lot, and I'm automatically be prepared to take 100, 200 ppm, so we can handle spikes all the way up to 1,000. So it's a very robust system. Since we know what we're going to be getting here, we went with the constant water situation so that we can make the calculations and set it and forget it, and we have the known value. That usually works well in places that have consistent load of what they're doing and not having food digestion situation with, anaerobic thermophilic digesters and things. And that's why the water's constantly running. Is it being fed with plant water eventually? Okay.
How we want to set is to change all the water in 1 week. This means that if we have a 30 cubic meter, it's about 1 gallon per minute. We will set a valve. There is 2 valves, one set and the other we close. When we will start with the air, with your process, we open the other one and we leave moving the fresh water inside. So you will have 30 cubic meter per 1 week, for a week.
And then
as a consumption.
So the way that the water gets disposed of is that through the overflow drain?
correct.
So what you introduce go out.
Where does the
This,
overflow train go back to
overflow.
the plant? I think that's what's on the original submittal drawings anyways, was to return to the head of the plant so that we'd have zero
It's
waste.
nothing.
We do suggest once a month, same time every month.
I suggest to give a look to the spraying system.
Yes, just making sure they're not clogged. That's the mission of keeping the health of the system. Measuring, so when the height of the shells, we track that every month. pH, don't need a full lab sample. Continuity, pressure drop, so you can see the pressure drop should be 1. And then from there, you can understand that the correlation of data from there. But we'll start, that's main, takes about 15 minutes. And drop sensor for pH, you can just drop it in and grab the continuity at the same time. Those are your 2 big indications. And if you look in there and it doesn't look right, it's probably not. Because that's how you'll clog the drains too. Because it is biological, so it'll operate. It's like a bad septic system. You'll start getting biofouling in the media layer and nasties you don't want. So 2 weeks is usually how long the bugs will stay alive if everything is there's no load or the fan breaks. The irrigation usually anything after 2 weeks we'd want to reinoculate. But outside of that, no need to. And usually. Tomato fertilizer, if it's been dormant for 2 weeks, will work.
And it's very complicated to explain why efficiency of the biofilter technology on the odor is so high. If you check chemical system and biofilter system, and you make the measure on the single compounds, I don't know, H2S, dimethyl sulfide, ammonia, maybe you get the same result, but on the odor it's completely different. So the efficiency of the biological, so the bacteria, is 2-3 times higher than the chemical system. So you use a chemical, but it's incredible. But there is no correlation between the efficiency on the chemicals and the odor. Even if you measure no chemicals, you can have odor. You have a different population of bacteria that manage different compounds.
Yeah, and the calcium in the system is considered a chemical component of it. It's really a hybrid.
Yeah.
It's a biofilter, it's a biotrickling filter, and it's partially a chem absorption system. It's just you're not adding anything.
This is important. For sure, we can check in the water, should be also nitrate, because nitrate, not your case, but nitrate in some cases steal calcium shells. So sometimes when you have a higher concentration of ammonia and the oxidation became nitrate, the nitrate steal calcium. In some process we suggest to check this one. But in this case, Justin, I think only the pH. Maybe we can check sulfate. Sulfate,
no, I think the load that we're going to see here is very low.
So very low.
Comparative.
For sure, we have 2 kinds of media. The first media is the size is bigger than this one, to have a low pressure drop at the beginning, because this take the more load.
So you have scallops and oysters.
The first is oysters, and the second is scallops. Yeah, the oysters are.
Yeah, they're more like a cockle.
Yes. Also, the calcium is difficult to steal from the oysters. Different chemical compounds.
Yes,
the envelope. Yes. The envelope.
The bivalve might use recycled tires. That's a big one. That one of the other medias we use at the Crumb Rubber. We did in Falmouth because that one, the ferry unloading station was a mess.
manage it. And also, if you want to change the media, it's very simple.